So we're learning about solving systems of equations using substitution. And get my camera together. All right, this is the substitution method. So there's 5 steps to this. Isolate, substitute, solve, second variable, point, also solution, it's also known as solution, and check. All right, those are the 5 steps. Isolate, substitute, solve. Then you're going to repeat these for your second variable. Only isolate if you need to, but you're definitely going to substitute and solve. And then you're going to come up with a point or a solution, which is your solution, and then you're going to check your work. So let's get started. Isolate. First thing you got to do is understand what the word isolate means. And to isolate means to be alone. In math, we're saying to get only one variable by itself on one side of the equal sign. Okay? That means that it should either be y equals whatever or x equals whatever. Right? So that's what isolate means. It means this is all alone. And this can be all alone on the left side or the right side, as long as it's all alone on the one side of the equal sign. That's what it means to isolate. So I'm going to give you a problem, and I just want you to practice isolating the variable, okay? So you can pause it and do it after I write it down. So we got x minus y equals 32. And I would like you to isolate the x variable. You can pause it here and give that a try. Alright, so if I want to isolate the x variable, that means I want the x variable to be all by itself, and then the equal sign should be right next to it. So that means in this case, I need to move this out the way. I don't want to move x over here with 32 because then it's not alone, and then I still have to do another step. So I have to do the opposite when I do the rewind step of solving equations. So plus y. What I have left, this cancels out. X is left over here. Equal sign. 32 is single, y is single, but 32 is a constant and y is a variable, so I can't put them together. So I'm going to write 32 plus y. I just isolated the variable. All right, let's try one more. 3x plus 2y equals 12. I don't know what it's going to be, and I would like you to isolate the y variable. Okay, let me turn my camera a little bit. Turn my paper so it doesn't look crooked to you. All right, pause it, isolate that y variable. All right, so the first thing I want to do when I want to isolate the y variable, I'm looking here and I'm saying, hey, I need to make sure this y is next to the equal sign and it's the only thing over here. So I need to get rid of this. So this is a positive 3x, so the opposite is negative 3x. And whenever I'm doing my rewind stage, I have to use the opposite to move it from one side of the equal sign to the other. So these cancel, leaves me with 2y, bring down my equal sign. And this is a constant, and this right here is married. I call this married, meaning it's a multiplication problem. And I can't combine these two because there's a variable x here and there's no variable x here. So I'm going to write this as minus 3x plus 12. Now, though I have this isolated, I have a 2 over here, so I need to get rid of this 2. This is a multiplication problem. The opposite of that is division, so I'm going to divide by 2 there. And then whatever I do to one side, I have to do to the other. I personally like to divide each term by this, so I don't make any mistakes. This cancels, so I got y equals negative 3 over 2x plus 6. I just isolated the y variable. All right, so now you know how to isolate the variable. That's step 1, understanding how to isolate the variable. So if we look at our sheet, zoom in, and it says the same thing. Get one of the variables by itself and one or both of the equations. And they gave us an example. When you're solving a system of equations, you should have 2 equations to work with. You're going to have 2. So in this problem, our 2 equations is y. Our 2 equations is y minus 2x equals 4 and y plus 2x equals 6. Those are our 2 equations. If you look at these, neither one of them are isolated. So I need to isolate the variable. And right now, it looks like it's going to be easier to isolate y because it doesn't have a coefficient attached to it. So as soon as I move this, I'm done. As soon as I move this, I'm done isolating it. So I'm going to isolate the y variable in this first equation. Y minus 2x equals 4 is the original problem. I want to move this so that y is on this side of the equal sign all by itself. This is in the rewind stage. I need to do the opposite, so plus 2x, and I have to do the same thing to the other side. Bring down my y equals, because this cancels out, 2x, and this is a positive 4, so plus 4. I just isolated the variable. Okay? So now that I've isolated the variable, I am actually going to go to the next step because I've isolated one of these variables already, and now I can use this as a substitution. Anytime I see a y in this second problem, I can plug this whole piece in. Okay? And the reason I want to do that is because I would like to work with just one variable. Instead of having x and y, it would be nice if all I had were numbers and the same letter. Because that, if I have the same letter, that letter is supposed to stand for the same missing number that we don't know. All right, so the next step is that substitution step. Okay, so I've isolated the equation for the first problem. My second problem was, let's zoom out a little. Okay, this is step 1. Step 2, my second problem was y plus 2x equals 6. Okay, so, and this right here, this was the second equation. Because remember, I have 2 problems. So anywhere I see a y in this second equation, I'm going to put all that in there. All right, so let's rewrite. So where I see a y, I'm going to put this whole thing in there. 2x plus 4, and then I'm going to just keep going with the rest of this problem. Plus 2x equals 6. So now I'm going to remember my steps for solving an equation. Can I distribute? No, there's nothing to distribute. Can I combine? Well, I have a 2x here and a 2x here. I could put those together. How many total x's do I have now? 4x plus 4 equals 6. Okay? Can I combine anything else? No. So let's try the rewind stage. Now I'm going to rewind backwards. And once again, my goal is to isolate this variable. This time, once I isolate this variable, I'm going to actually be solving for x. So to move it from one side of the equal sign to the other, I have to use the opposite. So I'm going to start with my constant, minus 4 on both sides. That leaves me with 4x. These cancel out. Equals 6 minus 4 is 2. Okay, and this is a multiplication problem. So I'm dividing on both sides by 4. Sorry, I ran out of the room on the paper. So go over here with me. So these cancel out. That leaves me with x equals 2 over 4. And that's also equal to x equals 1 over 2. Because I can divide both of these by 2. I can reduce and divide it by 2. And this will be 1 and this will be 2. So x equals 1 over 2. I'm sorry, again, you couldn't see that. Okay? So x equals 2 over 4. I reduce by dividing the top and the bottom by 2. Left me with 1/2, so x is equal to 1/2. So now I know what x is. X equals 1 over 2. That's important. Keep that. I'm going to draw a little cloud around it. That's very important. Because now I'm going to substitute again, because my variable is isolated. I'm about to substitute again, and I'm going to solve for y, because I don't know what y is. Okay? So I'm going to go back to my original problem. Zoom in. Here's my original problem. Y minus 2x equals 4. All right? So, get me another sheet of paper. I know that x is 1/2. So, y, and this is equation 1. And I think that's where some of us get confused is we're like, 2 equations, equation 1, oh my goodness, what is she talking about? So equation 1, our first equation is y minus 2x equals 4. All I'm doing is plugging in what I know. I now know an actual number for x. So I'm going to plug it in now. Everywhere I see an x, I'm going to put this in there. So everywhere I see an x, I'm going to plug that number in there. So y minus 2 times 1 over 2 equals 4. All right? So 2 times 1/2, I know these actually can cancel out. And that'll leave me with y minus 1 equals 4. Okay? Because we know this 2 is the same as 2 over 1. And then you can cross cancel. All right? So I need to isolate the variable again. That's what I'm trying to do. I'm solving for y. When we solve for y, that's the same as isolating that variable. All right, so I'm going to look at my constant. It's minus, so plus 1 on both sides. That cancels. I have y equals 5. Y equals 5. All right. So I've done step 1, which was isolate the variable. Step 2, which was substitute. Step 3, I solved. That's where I got my x equals 1/2. Then I did the same thing for the second variable. I didn't have to isolate it. I was fine without isolating it the second time. You can, but you don't have to. I substituted in x wherever x was. I solved, and I got 5. So now I'm going to give my point solution. All right? So your point solution is always an xy coordinate. Okay? So my x is 1/2, right solution, and my y is 5. Okay? That's what this is saying. Now how about I check it? Let's check it out. So, another sheet of paper. I'm going to write solution at the top and what my solution is. Okay. Go back to my original problem. All right. Back at my original problems. So let's plug it into the first equation. Wherever I see an x, I'm going to put that, and wherever I see a y, I'm going to put that. So the original problem says y minus 2x equals 4. Let's substitute. 5 minus 2 times 1/2 equals, and we're hoping it's going to equal 4. So let's see. We know these cancel out, and that'll become 1. So 5 minus 1 equals, 5 minus 1 is 4. Check. So it worked for the first one, because they're the same. Let's do the second problem. First equation. And I'm just going to keep labeling that so you get the idea, okay? Second equation. It tells us y plus 2x equals 6. Remember, wherever I see an x, I'm going to put in a 1/2. Wherever I see a y, I'm going to put in a 5. So 5 plus 2 times 1/2 equals, I want to know what that equals. I'm hoping it's going to equal 6. So this, we know, cancels out, and it becomes 5 plus 1 equals, 5 plus 1 is 6. They are the same. Check. Okay, so that's how you do it. If you had any questions, let me know. If there's a piece that you didn't get or you didn't understand, let me know. But as long as you just remember, labeling is so important, because we're starting to work with more and more pieces of these math problems. And so you have to remember what step you're at. You have to remember what pieces you have. And when you're doing system of equations, you have 2 equations. So you have to remember, okay, am I using this equation or this equation? Label them. Label the equation 1, equation 2, so you know which one you're working with if you have to do that. Remember, when you isolate the variable, say, okay, I've isolated the variable, now I'm going to use equation 2 and plug it into equation 1. So wherever I see a y in equation 1, I'm going to put this in, just like I went through. So everything you saw that I did, that's how I have to think. I think it in my head because I've done it more. But to start off, you're going to sort of have to be talking to yourself and give yourself that pep talk. So let me know if you have any questions. Hopefully this made sense to you. And have a good day.